So today we're starting a new unit, trigonometry. What do we know about trigonometry? Does anybody have anything they recall from middle school days? I heard people say that they were excited that it was trig when they walked in. So what do we know about it? Sine, cosine, tangent. What else do we know? You can use a calculator for most of it. What else? What shape does it pertain to?
Triangle.
What kind of triangles?
Right triangle.
Right triangles. Who remembers the little acronym that goes with trigonometry? To solve for a sine, cosine, and tangent. What's the little acronym? SOHCAHTOA. Okay. So all of that is coming back today. If everything I just said made no sense to you, it's okay. We're going to go through it all over again. But hopefully this will be a good intro. Pretty simple day. And then obviously it gets a little bit more spicier as we proceed through the week. Skills checks all week. One today, one Wednesday, and one Friday. It's just a quick 3-lesson chapter. Then you're going to have a quiz, and then a review day, and then a test. Okay? So 3 lessons, quiz, and test. That's it. Alright, so stay focused, and here we go. Trigonometric ratio. Okay? That is the ratio of the lengths of the sides of a right triangle. Okay, and it is related to the acute angles. So you have one right angle and 2 acute angles. Okay, the 3 most common ratios we talked about already: sine, cosine, and tangent. Okay, so we're going to go through this table here using this picture. Okay. One of us already mentioned, okay, the acronym that we use to solve for sine, cosine, and tangent, and it was SOHCAHTOA. Okay, and I'm going to write down what they stand for. So you have sine, cosine, tangent. What do you think O stands for? Opposite. So anywhere you see an O, it's opposite. What do you think A stands for? Adjacent. What does it mean to be adjacent? What does it mean to be adjacent to something? Next to, very good. And H stands for hypotenuse. Okay, so to find opposite over hypotenuse. To find cosine, you're taking the adjacent over hypotenuse. To find tangent, you're taking the opposite over adjacent side to find tangent. Okay, so sine of A, the way that you would abbreviate that is just SIN. A. On your calculator, sine button is here. Just says SIN. So these are the 3 keys that we're going to be working with: sine, cosine, and tangent for today. Okay, how do we find sine?
Opposite over.
Very good. Opposite over hypotenuse. Alright, so if we're looking at angle A, which is here, And we are looking for the opposite side over the hypotenuse. What is the opposite side of A? Little a. And what is our hypotenuse? C. So to find sine of A, it would be A over C. Okay, now let's look at cosine, abbreviated COS. Your angles will always be capital letters. Okay, how do we find cosine? Adjacent over hypotenuse. Okay, so still looking at angle A. What side is adjacent to A? B. Why is it not C? Because C is the hypotenuse. Very good. Okay, so adjacent is B, and then our hypotenuse is C. Okay, then we have tangent, our last one. Abbreviated just tan. And how do we find tangent? Very good. Opposite over adjacent. So still referencing angle A, what's opposite? Little a. And what is adjacent? B. Okay. Either by yourself or with your table group, I want you to do the sine, cosine, and tangent of angle B. Go. Shouldn't take you but 2 minutes. Sine, cosine, and tangent of angle B. Alright, Kelly, if I'm referencing angle B and I'm asking to find the sine, what side is opposite?
Little b.
And a hypotenuse?
C.
Very good. Chris Park, cosine of B, what side is adjacent? A. And the hypotenuse? Very good. Madison, tangent of B, opposite
B.
and adjacent? Very good. Okay, so this essentially is the basis and the foundation of our trig ratios. Okay, and now obviously we're going to apply some numbers and application problems. Okay, and start using our calculator. But do we know how to make our ratios? Do we know what opposite side means? Adjacent side. Okay, so far so good? What? Adjacent means next to. Okay, so you're always going to have an opposite, a hypotenuse, and then a next to. In this case, it would be opposite, next to, hypotenuse. Alright. Turn the page. Example 1. Find the sine, cosine, and tangent of A and B. Express each ratio as a fraction. Okay, so express each ratio as a fraction. Let's go A first. Okay, so we're referencing angle A. Sine of A, how are we finding that? Opposite over hypotenuse, which is going to be what? What's opposite? 5, and your hypotenuse is? Awesome. Box it, you're done with that one. Okay, cosine. How do you find cosine? Adjacent over hypotenuse. What is adjacent to A? 12, and the hypotenuse? 13. So box that. You're done with that one. Last one, tangent. How do you find tangent? Opposite over adjacent. Again, what is opposite of A? And adjacent to A? Very good. Okay, on your own, do all of the ratios in reference to angle B. Angle B. Hannah, what's sine of B? 12 over 13. Very good. Emma, cosine of B. Very good. And Ishmael, tangent of B. What is opposite of B? 12, and the hypotenuse? Or not the hypotenuse, the adjacent angle? 5. Do we agree? So far, so good? Alright, go on to do number 2 on your own. Same thing. You're finding the sine, cosine, tangent of S, sine, cosine, tangent of E, and leave it as a fraction. I'll call on a random 6 people. Alright, Fernanda, how do we find sine? Opposite over hypotenuse. As you can tell, I'm starting to abbreviate more and more as we're writing these, so now I'm O over H. Okay, and what did you get for opposite over hypotenuse, Fernanda? 3 over 5. Do we agree? Very good. Courtney, how do you find cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse, and that ratio is?
4 over 5.
4 over 5. Do we agree? Awesome. Chris Kim, tangent, how do we find it? Opposite over adjacent. Your ratio is 3/4. Do we agree? Awesome. Katie, back to sine, how do we find it? Opposite over hypotenuse, and the sine of angle E is what? 4/5. Do we agree with her? Awesome. Andrew, cosine, how do we find it? Adjacent over hypotenuse, your ratio is? Do we agree with him? Yes, okay, awesome. Devin, tangent, how do we find it? And the ratio? 4/3. Very good. Any questions on writing ratios now that we've thrown in some numbers? Alright. Next part is actually using our calculator. Okay? So find each value using a table or a calculator to the nearest thousandth. Okay, so we have cosine of 41 and sine of 78. The big thing here is if your calculator is not in degree mode, you will get it wrong. Okay, regardless of whether you typed in the right strokes on the calculator, if it is not in the correct mode, it will give you a completely different answer. So on your calculator, it's kind of hard to see up here, but make sure you press mode, and then on the fourth row it says radian and degree. Make sure your degree mode is what is highlighted. Okay, I think the default setting is always radians. So before your test and quiz, I'll remind you, but if you clear your calculator for whatever reason during and you forget to go back and reset it, then you're going to get all those answers wrong. Okay, so make sure that it's in degree mode. Okay, once it's in degree mode, just hit second quit. Okay, and then all you have to do is type it in. So the first one was cosine of 41, so you're hitting the cosine button, typing in 41, and pressing enter. If you round that to the nearest thousandth, what would be your value? 0.755. Thousandths is 3 places, do not forget. Hundredths is 2 places. Okay, so now try sine of 78. Carson, what'd you get for sine of 78? 0.978. Do we agree? Okay, so again, rounding will be huge here, because on your CBAs and stuff, it'll tell you to round to some place value. And if you don't know how many places that is, that's a really silly way to get something wrong. Okay, rounding was like elementary school. Alright. Find the missing measurements. Alright, so looking at example A. Okay, what side are we given? The hypotenuse. So you know for sure you can work with something that has the hypotenuse. So that eliminates what option? Tangent, right? Because with tangent, you have to have opposite and adjacent. Okay, and we know that we only have the hypotenuse. Okay, so we're working with sine or cosine. Which one you're working with depends on which angle you choose. Do we want to work with 21 degrees or 69 degrees? Near and all, because you said it, we're working with 69 degrees. Okay, so 69 degrees. This is our reference angle. What side is our x? Adjacent, and our hypotenuse is 9. Okay, so are we doing sine or cosine? Cosine. So cosine, before we were just writing our points or our angles, A, B, C, etc. Now we actually have this angle measurement. So we're going to have cosine of 69 degrees equals, same thing applies, adjacent over hypotenuse, so what's my ratio? X over 9. How do you think we're going to solve for x? Yes, you're going to have to use your calculator, but how are we going to get rid of this 9? Multiply both sides by 9. Okay, so now your 9's cancel, and you have 9 cosine 69 degrees equals x. This technically should be written here. 9 cosine 69 degrees equals x. So, type that in your calculator just like that. 9 cosine 69 degrees. And what do you get? Round to the nearest, we'll go 100. 3.23.
What unit do we use, or do we just leave it?
You can just leave it.
Okay.
Okay, had we used 21 degrees, what would have been our equation? If we use 21, which one would we be using? Sine. So you'd have sine of 21 equals what?
X over 9.
X over 9. So x would equal what? As far as the equation goes. 9 sine 21. And type that in your calculator. What do you notice? It gives you the same thing. Okay, so you'll know you did it right if you end up with the same thing. Alright, let's look at letter B. Which angle do you guys want to work with? 53. Okay. If we're working with 53, which trigonometric ratio are we going to use? Sine. Sine of 53 equals what? X over 13, because we're opposite over hypotenuse. How are we going to solve for x? Multiply both sides by 13. So our equation would be what? 13 sine of 53 degrees. And so x equals what? 10.38. And you can just write units. Alright, C, you have two different ones to do, okay, and D. With your table, or by yourself, or your elbow partner, whatever you want to do. Okay, I'm going to give you 4 minutes, okay, to do C and D. C and D. Yeah.
How do you know which one you use?
What do you mean, which one to use?
How do you know when you use sine and cosine?
Because you're looking at your angle here. You know that you need to solve for x. What is the relationship between x and 53? What is the position of x? It's opposite. And then what other measurement are you given? The hypotenuse. So you know that you're working with opposite and hypotenuse, which is sine. So you have to look at the relationship between the sides you're given. I'm going to switch things up on you. We'll actually come back and do C together. Do D. Because C is a little bit different than anything we've seen before. Do D. After you're finished with D, while you wait, you can challenge yourself and see if you can figure out letter C. Alright, let's look at D. So in D, I'm only given one of my acute angles. So I know for sure my reference angle is my acute angle of 50 degrees. Okay, so let's look at one variable at a time. Okay, let's solve for x first. Okay, x is in which position in relation to 50 degrees? Opposite. And then the other length you're given is what?
Hypotenuse.
Your hypotenuse. How do you find opposite over hypotenuse? Which ratio is that? Sine. Okay, so you're going to have the sine of 50 equals opposite, which is over 11. So how would you solve for that? X equals what? 11 sine of 50. And when you type that into your calculator, what do you get? 8.43 units. Okay, now let's look at y. Okay, so we've already done x and we're looking at y. What is y's position in relation to 50 degrees? Adjacent, and then again we have hypotenuse. So how are you going to find y? Which trigonometric ratio? Cosine, which is equal to adjacent over hypotenuse. So you had the cosine of 50 equals what? Not yet. Adjacent over hypotenuse. What's my ratio? Y over 11. So if I solve for just y, I get y equals what? 11 cosine of 50, which equals what? 7.07 units. Alright, so I told you letter C was a little bit different than what we have seen before. Okay, but it's not too hard. Okay, let's look at solving for x. Okay, we are currently given 54 degrees. Okay, x is which position? Hypotenuse. And then I have 8, which is which position? Adjacent. So when I have adjacent and hypotenuse, what am I using? Cosine. So you have cosine of 54 degrees equals adjacent, which is 8, over hypotenuse, which is x. Okay, before we've always had our unknown in our numerator, so we just multiplied and called it good. Okay, how would I get x by itself now? I would have to multiply both sides by what? In order to get x out of the denominator, I need to multiply by what? X. So now I have x cosine 54 degrees equals 8. X is still not alone, so now what do you do? How do I get x by itself? This is x times cosine 54. Divide by cosine 54. Now I have x equals 8 divided by cosine of 54 degrees. So type that in your calculator. What do you get for 8 divided by cosine of 54? 13.61 units. If you don't know how to divide it, it's just typing it in 8 divided by cosine of 54. Alright, trying going to solve for y using 54 degrees. Y is in which position? And 8 is in adjacent. Opposite and adjacent use what? Tangent. So you have the tangent of 54 equals, what's our ratio? Y over 8. So how would you solve for y? Multiply both sides by 8. So y equals 8 tangent of 54. So what does y equal? What is it? 11.01 units. Okay, so the first couple pages were very simple and basic. Okay, C and D, like I said, it started to get a little bit more spicy. Okay, so you can expect these types of problems to be what you see on tests and CBAs and what have you, or a skills check maybe. Okay, so make sure you're comfortable with solving for your unknowns, especially when there's two variables. Alright, last page. Given a value for one of the trigonometric functions, find the value of the other two functions. Alright, I'm going to make theta, which is an angle, it's just a fancy word. Okay, this angle here. If I know the tangent of theta equals 5 over 12, tangent is what sides? Opposite over adjacent. Okay, so where is 5 going? Opposite, so here or here? A or B? A. Okay, so 5. Where is 12 going? Next to it. Okay, now I'm going to challenge you because what do we have to know in order to solve for sine and cosine? Hypotenuse. So solve for the hypotenuse real quick. If you know your triples, it'll be easy. What is C equal, or your hypotenuse? 13. Alright, so still referencing theta, our same angle. Let's look at sine of theta. Okay, in words, how do we find that ratio? Sine is what? Opposite over hypotenuse, so what would our sine ratio be? 5 over 13. And cosine in words, how do we find it? Adjacent over hypotenuse, and that would be what? 12 over 13. So there's our three ratios. Okay, I want you to do letter B and C on your own. Keep theta this angle here. Okay, all of them are triples, so you shouldn't get any decimals as far as your lengths go. 1 minute. Alright, it looks like all of you are done, actually. Alright, sine of theta equals 3 over 5 represents which side? Opposite and hypotenuse. Okay, so 3 and 5. What is the length of our missing leg? 4. Which results in our cosine being what? 4 over 5. Do we agree? Do we agree?
Yes.
Yes, and our tangent is 3 over 4. Any questions on letter B? Alright, letter C, we're given the cosine, which corresponds to what sides? Adjacent over hypotenuse. So we have 24 over 25. And what is our missing leg length? 7. Okay, so our sine would be what? 7 over 25. Do we agree with Kelly?
Yes.
Awesome. And our tangent would be what? 7 over 24. Okay, again, this is another type of format that you will see in your future. So, is there any questions on this last page, A, B, and C? No questions? Okay, this little table is just in place of a calculator, say you weren't given one. Okay, so, for example, we had cosine of 41. You find 41, look at the cosine, 0.754. And here we have 0.755 because we rounded, but it's the same thing. So if you would like to use the table instead, or let's say you go home and actually do your homework assignment, okay, you can use this if you don't have a calculator. Okay, so that is all.